So, hello everybody, my name is Alfredo, and I'm going to try to present you the technical aspect of this project. At least I will try to. I don't know how much technical stuff you may know, so I just reduced all the text of my slides to this one, the title. Right, so I'm going to try to present you what is visual intelligence and the Terminator. Let's see about this stuff. All right, let's get started. So all about this presentation will be basically of automation. Automation is something that is usually represented like by a picture like that one. So when we think about automation, we have a perfectly defined environment where repeatedly like actions that are repeated at perfect precision are performed by machines. They do it very fast. They do like magically, right? So we may be, I don't know, scared that they are, wow, they are better than us. Not really, because if you just introduce some kind of not well-defined environment, you're gonna be very actually screwed. So we'd like to give machine vision. Why is that? Because with the vision, they can adapt to what they see, right? So, and also they can perform different kind of tasks that are more, they require more capabilities. For example, this one, they are trying to find out where a package should be sent, right? So they need to have the vision to be able to perform very tasks that are in an unconstrained environment. So let's see, for example, what is the state of the art about this kind of robot. So here we have a nice robot that is trying to fold napkin. So this video is fast forward 50 times. So it's kind of going faster 50 times the reality. So basically for folding one napkin, it takes like 1 hour. This is like a very, very, very easy task mom does every day, right, for us, perhaps. And for this guy, it's so difficult, right? It first has to find the thing. Then he has to look around, find out which is the right way, then right, still looking around, and more looking around. Okay, nice, found it. Then he tried to twist and see what is his end, what is the napkin, right? So that's kind of lovely, right? And of course, like Senator Tom Coburn from Oklahoma said it is a waste of money, of course, right? Yeah. I mean, it can look like a bit, you know, useless, but this is a very, actually, complex thing that for us is so easy, right? So, all right, let's say we want perhaps more human-like vision to our machines, so somehow we want to give them some kind of skills, right? Let's go forward. This guy is kind of boring. All right. Again, sorry about that. Okay, so what if we bring technology to our houses, right? Wow, buttons everywhere. So it's going to be actually even more detrimental than helpful, right? You have to find out what to press to switch on the light. Is difficult, right? I don't want that stuff. Also, more buttons here. I would like, at least myself, something, technology that would adapt to my needs, right? So I do perform something, and I would like this stuff to learn from what I do and just behaves accordingly my needs. So basically, we have something like that. For example, this guy. This guy mows the lawn for myself instead of I'm just there reading my newspaper. And for example, if the grass has grown too high, it's gonna cut it for me. Or if tomorrow is gonna rain, then it's gonna cut it today. Otherwise, it's gonna get stuck tomorrow with the rain. And if it's gonna run low of battery, then it's gonna seek the outlet, right, for charging. But what if this guy would be like this one? So he also can water my plants in-house, right? It would be nice. Why is that? Because this way, if we give them at least a kind of human vision capabilities, they're going to be slightly more independent, but they're going to help us even more. Moreover, let's say I forgot to go to see Grumpy yesterday. So this guy can also help me, right? And I can say, oh, look after Grandpa because, I don't know, he needs some kind of help. So this kind of technology actually would improve our lives. So that's nice stuff, I would say. So and it can also cut the grass and, of course, bring dinner, right? I don't know if you can cook, but I wouldn't try. All right, so another example of automation that we can have, because I said everything is about automation, I would say, this kind of computer vision machine thing. This is what it could clean the house, in my house, but still, this is too, you cannot do many things, right? So if I go home and there are clothes on the floor, I would like that guy to pick them up and, you know, clean the room, right? So, and that works only if you provide these machines a kind of human vision algorithm. So they are able to pick my, I don't know, pants and then fold them, not like the other guy in 40 minutes. So again, one word, vision. So human-like vision, actually. So this way, we like, at least I like with my, and also, yeah, I would like to give them the abilities to perform some tasks that are kind of not trivial for machines, but they're perhaps, you know, easy for us. How do we get started? So we have machines, we know we have computers, but where do we start? I would say, let's start from what we have already, human brain, right? The human visual system is a very great example of what we want to emulate. Its algorithms, they work. How do I say? How do I know? Because, I mean, actually, I can see these things, I can handle them, I can fold napkins kind of faster than the guy before, almost. All right? So again, so we have the human brain, and then we want to get out some algorithms. And then when we have the algorithms out from the wetware, we want to put them into our hardware, right? So this stuff is called artificial neural networks. So in this picture, we see a very abstract way of representing a neural network. I will try just to make it very you know, abstract and easy to understand, so it's kind of not, you know, boring stuff. So we have a lot of circles, right? Very colorful circles. On the left-hand side, we have those blue circles. They represent the input neurons. The input neurons are basically sensors. Like, for example, if we are speaking about the human visual system, they would be like the cones in our retina. Then we have a series of different layers of red circles that might be our neurons in our brain, and each layer is processing what comes from the left side, hand side. And then at the end, very end, those green guys over here are the kind of hierarchical representation that comes out of this kind of processing. And basically, they are actually the same kind of circle. So everything is quite alike. But since are the last layer, I made them green. So it's like last. All right, so information comes from over there, where we have the input neurons, where they sense the world, basically. And then the information is, goes through the network and is processed by the different neurons. And at the end, of course, we will have the final representation provided by the algorithm. All right, so how does the information go through this guy, right? So at the beginning, every singular layer is connected to every other neuron in different layers. So the first layer is connected, each neuron is connected to all the other neurons. It took ages for drawing that thing. Anyhow, all right, so then we have a process that is called training, where we provide the machine examples of, for example, data set of images. And as they said, Shannon and Fabian, this data set are based on our culture, right? Because the data set are made by humans. So somehow these machines will eventually learn things that are related to our society, our way of thinking. So basically, again, we have a training process, and this training process, what it does, in very easy terms, is basically strengthening some connections and weakening others. So at the end, we will end up with some kind of configuration that looks like this one. So basically, this whole network will perform some operations that we don't know actually how it performs those operations. But it does perform those operations with some kind of connections that it will learn by itself, right? So this may be scaring, perhaps, because we don't actually know how it works, right? Because it learns by itself. So I provide images or whatever data from that side. I ask to have a specific outcome, and it will figure out by itself or himself, I don't know, let's say itself, how to end up with the correct answer, right? With the correct prediction. So this thing may be a bit scary because it's like a black box, right? So what we have done here for this exhibition has been basically getting rid of this guy here, and then looking from inside how things are seen by the machine. So the first thing that is the easiest one, I would say, okay, let's look, that's a symbol of an eye. So let's look at the input, right? So the input basically would be our camera input, right? So if you go outside, you just turn the knob on the bottom up to the extreme left, you will just basically see what is coming from the camera. Then you can, of course, turn and go in a deeper levels. So for example, in the first level, from there, you have several neurons. So with another knob, you can change and select different maps. Each map is connected to a different feature map. Kind of weird terms, but anyhow, basically you can try outside, it's not that difficult. So you just try and turn those knobs, and you will see different kind of filtering of the input. Basically, the first layer, what does perform is basically some kind of edge recognition. So you will see, for example, a lot of bars in this direction, bars in the other direction, basically bars. But of course, you can also turn another knob, and the other knob will allow you to change layers and depth through the network. The more in depth you go, and the more will be complex the kind of pattern that the network will be showing you on the screen. So what I'm actually showing on the screen is kind of back projection of these patterns into the input space. If you didn't understand what I said, it's fine, doesn't matter. All right, so let's go forward and let's see what's next. Next is gonna be what I managed to do and make work, if it does start, in the lab. So here I'm doing a Google search, and my algorithm actually finds out that I'm looking at my computer. That's quite right, with an accuracy of 90-something%. So this is actually looking at the green guys on the right of the network before. So I was looking for fridges, and this guy told me refrigerators. So with a 99% of accuracy. So again, the classification on these algorithms may not be perfect, but in this case, it's very high. And I'm not cheating because I'm just getting images from Google. So it's kind of very, just look for some child beds, and it's gonna, I'm just showing the bed to the algorithm. It tells me, oh, with 97%, that's a child bed. Wow, nice. I can tell myself. But anyhow, this is kind of very difficult task, trust me. And also, actually likes very much puppies. I don't know why. I mean, perhaps because I made it anyway. So anyhow, so this is what I do in the lab, and it's kind of cool, right? It's funny. If you want to join us, you can. You are very welcome to. So, okay, you can see other pictures. I don't know if you want to see more. But still, I'm circling there on the top corner the accuracy, and it's kind of astonishing when you have like that 100%. It's like, are you cheating? I mean, 100% is like cheating, no? But it's true. Like, it's from Google. Like, I didn't do it myself. I just Googled those images, and I showed those images to the algorithm. All right, so let's go forward. Am I the only one working on this stuff? Nope. There are other people like them, and yeah, I would like to work there. Or perhaps also here, actually, perhaps. And there is another one. So basically, these three guys are the main three guys working on this topic. And basically, we are doing something very quite similar to what they are doing. They have some sort of a bit more resources, perhaps, than us, but still we can make something work, right? So you see before it was working. Yeah. All right, so let's go forward. So what's next? Right, so I have to, I think, go back to the topic of this kind of chat, right? The down or doom. Da, 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 da. All right. Okay, I don't know. Of course, as you can understand, I'm for the down thing, but anyhow. So shall we be scared to give human capabilities to machines? Well, let's go forward. So this is actually how the current impersonification of a machine that can see, it can looks like. It's kind of, you know, they could have spent more time to make it a bit more nice. But anyhow, so this guy here can actually even be dangerous, right? If you don't have very nice programmers, it can be even actually hitting someone, right? But let's say it's Google, so it's going to work, right? Okay, so anyhow, so every time in the human history, every technology has always have two sides. They have a good side and a bad side, right? Fire, it makes me cook, so it's a very good thing, but it can sometimes, you know, burn cities, and that's bad. So also this one, this guy, as every other technology in the world, they always have two sides. It depends how you use them. Or it's like, you know, it's like the coin. You have always two sides. So the first side, let's say this first side that I like more. Perhaps this one allows me to read a book instead of driving. It allows you to talk to your family, like you have to call your mother every week, and if you don't do it, you're in troubles. So you can call mom instead of driving home. It's like, hey, what's up, whatever. And or also, you can also spend time with your kids, right? You're gonna take your kids from school, and then you can play with your kids. Like, I don't have a kid now, but some of you may have. But still, like, we don't have time, right? And the most valuable thing you may get from technology is time, because time is a finite amount, right? You have seconds, minutes of hours, years, whatever, your life. Let's say 100 years. They are 100. They are not 101 or whatever. It's finite, right? So time is something kind of very important. And like Albert Einstein says, every minute you spend angry, you are just losing 60 seconds of happiness. So be smart. Don't get angry too much, right? So again, if you can really automate and increase the automation, so if you can keep financing those kind of researchers in the lab, so if you can go forward with research and of course improve automation, that will just give you time, and time is invaluable because it's the only thing you actually own, right? At least now that there is no any more slavery things. But really, it's very important. So again, this guy, even if he looks dumb or whatever, really allows you to have more of these precious things. All right, so as I said, there is a good part, that's more time for you. There is a bad thing, and like someone may get angry, right? Because they see their jobs just replaced by some kind of automatic machines. All right, sorry. But anyways, okay, let's just without joking, he may have troubles. He may have troubles in like losing the job, but he will be able to use his capabilities for something perhaps more important. He can learn new skills. He can, you can do more things if you don't have to do those tedious jobs. One more good part. So this coin has three sides, right? There's a good thing, a bad thing, one more good thing. So this is the car crash fatalities in the US. I just reported here the first 10 years of the 21st century. This is kind of scaring, just looking at the axis, right? So it's like I put tens of thousands of deaths. That's really like, that's really scary. I just went back to Italy last month, and my friend, oh, you don't have more that friend. What's happened? Oh, car crash. Like, no, no, it doesn't work, right? So, I mean, there are several tens of thousands of useless, pointless deaths happening for no reason, right? Why that stuff should happen, right? So, if you are able to have a machine, a car that drives itself, And you perhaps have drink a bit, but you say, all right, that's fine, I may go home, right? I don't want to sleep here on the street or whatever. Then this thing, this technology, will will save lives, right? So that's kind of important. So it can give you time, but it gives you times also if your time, it will also make your time longer. So if your time was, I don't know, you may be in one of those, you may have free time, like time that wasn't belonging to you is going to be given to you, right? So I think this kind of automation thing may be scaring, it may be like kind of what's happening, right? But it's good. So I'm for the, as I said, for the down thing, right? So I would say, yeah, actually, I have said most of what I wanted to say. The last thing, yeah, perhaps someone may want to see, may say like, oh, these machines are going to get angry. They want to get your atoms if you have read the book. Or they want to, take over the world. They want to, no, I don't think they have feelings. Feelings, what are feelings? Perhaps they are just chemicals released by the amygdala in your brain. They are like, and so what is this stuff? They just have the kind of higher level intellectual capabilities of performing a task, perhaps better than you. And perhaps you don't want to perform the task at all, right? So technology is good. All right, so I wanted just to say thank to that thing over there. That's where I work, actually. I've been working for 3 years now. It's eLab, and it's a laboratory here in Purdue at the Weldon School of Biomedical Engineering, where we have this awesome supervisor that's down there, and I'm really thankful to him. He also allowed me to stay here in his place, and it's a great honor. And of course, we are at Purdue, so boiler up, right? All right, thank you very much.